Flack math! Give me some math and I'll give you some flack. Flack math!
Alright, the supply curve for a product is represented by the function y equals 1/2 x plus 35. And the demand curve is represented by y equals -1/5 x plus 56, where y is the price of the product in dollars and x is the number of units sold. What is the optimum price of the product? How many will sell this price? So you basically just need to figure out where they intersect. What point works for both of them? So you could graph it, or you could use substitution. Graphing it would put it right here at 1/2. This is 35. 1/2 would be up 1/2, up 1/2. And then 56 is up here. So it kind of goes like this. So where does that meet? Where do both the x and y meet? Well, you could graph this out and figure it out, or you could set this equal to that. So I'm just plugging that in for y. So -1/5 x plus 56 equals 1/2 x plus 35. Okay, get the x's on one side. I'm going to add 1/5 to both sides. 1/5 plus 1/2, so 2/10 plus 5/10 is 7/10 x. I'm going to get rid of 35. 21. Multiply both sides by 10 and divide by 7, and you get x equals 30. So that is the optimum price of the product. So if I plug that in, I need to find y. The optimum price of the product is going to be 1/2 30 plus 35. So 15 plus 35 is $50. Okay, product sold 30. So that's kind of a complicated one. Maybe I'll make that extra credit. Sound good? Are you okay with that, Tori?
I think you should.
All
yeah.
right. All right, number 12. In the circle below, use the expressions for the segment lengths and write and solve an equation for x. So what do we know about these? Well, this is nice because it's all proportional. Okay? So it's all proportional, so that means 7 is to 5x over 3 as 3 is to -2x plus 7. It's proportional. So if you look at it, you can see the proportion right here. And you can just use the fish method or do cross products to figure it out. So that's 7 times -2x plus 7. And that has to equal 3 times 5x minus 3. Okay? So -14x, I'm just distributing, plus 49 equals 15x minus 9. Lots of algebra so far. Okay? So add 14x to both sides, and you get, and I'm going to subtract or add the 9 to both sides. So I'm going to get the x's over on the right, so they're stay positive. Get the constants on the left. Okay, so you get 58 equals 29x. So divide by 29 and x equals 2. All right, is that what it does? Solve for x? Yeah, to write and solve an equation for x. So you could figure out the rest of the lengths if you wanted to, but this is it. X equals 2. That's all it asks you to do. Okay? All right, moving on. Number 13. The equation of a circle is blah, blah, blah. What is the equation of the circle? If it is translated 7 units to the left and 3 units down. Well, if I were to graph this circle, it would be at the center. Where's the center of the circle? Can you guys remember that? Where's the center of this circle? Do you remember how to figure that out?
I can't see the equation.
I
Yeah,
don't remember anything.
it's kind of,
I mean, it's the opposite sign. If it's
Yeah.
plus, then it goes down.
so if it's x minus, if it's x, we're, left-handed mousing, I wouldn't recommend it. So if it's minus 4 minus 3, then the center is 4 comma 3. Okay? So and the radius is 3, right? Because it's a radius squared. But it's being translated 7 units to the left and 3 units down. So minus 7 minus 3. So that's negative 11, and then 0. Okay? So that's
on 2, please.
that's where,
on 2.
no, negative 3 comma 0. So that's where the center is now after it's been translated. It hasn't been dilated, so the radius is still the same. Okay? But it just was translated. It went 7 down and 3 left. So I just subtracted 7 and subtracted 3. So here's my new center. So how do you write that equation? And this time it's x plus 3 squared plus y minus 0, or just y squared, equals that same radius squared, so it's still 3 squared. Okay? So they get, what is the equation of that circle? That right there. Okay? Does that make sense? All we did was move it, and you could have graphed it if you wanted to. 1, 2, 3, 4. 1, 2, 3. This is where the center is. If it goes 7 down and 3 to the left, then it's right here. Okay? Either way it works. Oh, wait. No. Did I mess that up? Yeah, 4 over. Oh, I did mess it up. You guys didn't catch it. So 4, 3, the x value is 4 and the y value is 3. So you're subtracting 7, you're going 7 down and 3 units to the left. So this is what happens. So your center is at 1, negative 4. So 1, negative 4 is right there. So your equation is x minus 1 parentheses squared plus y plus 4 parentheses squared still equals 9. Okay?
Doesn't it
Difference.
say 7 units to the left and 3 units down? So 5.
Yes, it does. So forget everything I just said.
Oh my god.
I just crossed everything out. Thank you, Jamie.
All right.
Can we just
So-
skip this question?
Can we make it extra
Extra
credit
credit?
instead of
No,
11?
no. It was,
Instead of 11?
I was right the first time. I just read it wrong 2 times. I read it wrong the second time. I read it right the first time. But then I was like 7 units. I don't know. So basically, you're subtracting 7 from the x coordinate of the center and no, the y coordinate. Yeah,
What?
I'm
Let's
done.
just move on.
I'm done. Number 14. Here we go. I just want to eat that food, so I'm distracted. Equation of the circle is blah blah blah. If D is the concentric with C, that means it's inside, has the same center, and has a radius of 3 instead of 4. What's the equation? Okay, so here's what's happening. Concentric circle. This has a radius of 4. This has a radius of 3. So instead of 16, it's going to be 9, right? Because 3 squared equals 9. But it has the same center. So everything on the left is still the same. So it's still x plus 2 parentheses squared plus y minus 1 parentheses squared. That's it. That's the only thing you're changing is just the radius. So it's still the same center. So the left is going to be the same. The right just changes. So instead of a radius of 4, it's going to have a radius of 3. So when you write the equation of a circle, you have to square that radius on the right. So it's equals 9 instead of 16. Okay?
Okay.
All right, number 15. Here's our dilation. Okay, apply a dilation to triangle ABC if the scale factor is 1/2 and center is at D. Center D. Okay, So we have to not only cut everything in half, but we cut the distance in half as well. Okay, so if this is A, B, C, and this is D, bless you. Okay, how do I estimate the dilation of that? Well, everything is going to be half the distance. So if this is a distance here, half of that would be right there, A prime. If this is the distance to C, half of that would be right here, C prime. And if this is the distance to B, then half of that would be right here, B prime. So here is my new triangle. So just cut the distances in half to each vertex. That's all you have to do. Okay? Does that make sense? All right, in the diagram below, find theta to the nearest tenth of a degree. All right. So what do you want to do? We could do a couple things, but looks like trigonometry. What will help you find theta in this example?
So you have adjacent and opposite. So
Yep.
you mean and.
Yeah, so the opposite of theta, you have the opposite of theta and you have adjacent to theta. You don't have the hypotenuse. So when you have the hypotenuse, sine and cosine are nice, but you just have opposite, and so tan of theta equals op over adj. Well, opposite is 19, adjacent is 13. So tan of theta equals that. But that's just going to give you tan of theta. If you do 19 divided by 13, what's going to give you theta? What's going to give you theta? How do you get theta now?
You have to get it by itself.
Yep, so how do you get rid of the tan?
I forgot what it's called again. It's -1.
Inverse tan, yep. So you're going to inverse tan both sides. So you definitely don't want an inverse tan this summer.
Isn't that
Sure, you gotta
16?
see what I did there? No, it's 19 and 13.
No, I mean the question.
Oh, yeah. Yes, 16, sorry. I'm a mess. I'm distracted by yumminess. It's getting cold every second. Okay, so inverse tan. So I'm going to do this on this calculator, blah, blah, blah. I'm going to go second tan button. So inverse tan, and then 19 divided by 13, other parenthesis, equals 55.619. Let's see, round to the nearest tenth. So theta equals 55.6, and not equals, but approximately. Okay, don't forget to round it. Some of you guys are not rounding. You're like, I don't have to round. That doesn't apply to me. Those rules don't apply. Next thing you know, you're going to be in a mental hospital, addicted to drugs,
Whoa.
because you decided
Far.
that you don't have to round, and that just affects the rest of your life.
Because the butterfly effect.
Yes, butterfly effect. Have you seen that movie?
No, but I was thinking because
It's a cool movie.
if you weren't babysitting.
Okay, 17. Find the perimeter of rectangle whose blah 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 blah.
I had to get out when the place started.
You're not loud at all. Okay, -3, -2. There's 1 point. -8, -2. Blah blah.
It's the scientific way just to do.
Oh, look at that. Is there? And look, you don't have to use a distance formula because they're all. It just goes from a -2 to another -2. So we got -8, +9 up here, -8, +9. So this is -8, comma -2. If you want to graph it, you can, but you don't have to. And this is -3, comma 9. This is -3, comma -2. Okay, so how do you figure that out? You can find the distance between these by just subtracting 9 minus -2. and that equals 11, right? So if that's 11, that's 11. Okay, the distance between here is going to be -8 minus -3, which is also a positive 11, which is graphed terribly, sorry. This is, no, -8 minus, no, we're good. No, yeah, we're good. Blah, blah. So that's -5. And this is -8 minus -3 again, which is also -5. So perimeter is 11 plus 5 plus 11 plus 5. So 22 plus 10 is 32 units is the perimeter. Does that feel all right?
Yes.
Sounds great.
Okay. All right, number 18.
Wait, that was 17. Wait,
Yeah,
that
I
was 16.
said that was 16, not 15. This was 15.
Ah,
That was 14.
You did forget to write 14 there.
Okay, well, will you understand it if all my numbers are J?
Yep.
Okay. No, Eva.
That's so cute that you think I look at your practice tests. Okay, number 19. No, 18. Ah,
we just call it a day right here, right now.
we should, but I'm stubborn. This is the last math some of you are ever going to get from me. Hey, you're both pretty. Now shut up.
I know.
Okay, number 18, the two triangles shown below have a similarity ratio of 3 to 5. So I can do a little chart here. If it's a 3 to 5 ratio, then I can just apply that. Determine the ratio of their areas. Oh, okay. So what's the area of the ratio? What's the ratio of the areas? Sorry. If this is a one-dimensional ratio of 3 to 5, what's the ratio of the areas?
Wait, it's
You've gone too far.
300 is the 5, and then we just make it like
So it'd be 3 squared, 5 squared, right? So 9 to 25 is the ratio to the areas.
Wait.
That's something you need to remember.
9 squared, 5 squared.
It's
So it's 9 to 25 squared.
Okay. So here's the deal. Now that we have the ratio of the areas, we have to figure out the area of the bigger one. Okay, and that goes with the 25, and the smaller one goes with the 9.
it's 300.
So it is based on side divided by 2, which is 300. So area of the big triangle is 300. So let's set up a little proportion. 9 is to 25 as X is to 300. How many quarters are in $3?
There are
4 to 12.
12, wait, 4,
12.
12.
So the area of the smaller triangle is 108. Or if you fish method that, 2,700 divided by 25 is 108. Okay? Does that feel okay, guys?
Yeah.
Good. All right, number 19. So remember, to find the ratio of the areas, just square them. Vector V makes a 29-degree angle with the horizontal and has a magnitude of 5. So it looks like this. 29 degrees is about there, and it has a magnitude of 5. So 29 degrees. Do you see that visual there? So decompose the vector. What does that mean? Well, that means figure out what the x is and figure out what the y is. And decomposing the vector means say, okay, you're going to go right this much and left this much to get there. All right. So how do we do that? How do we find x and y?
What's trigonometry equations?
Trigonometry, yeah. Let's find y. So sine of 29 is going to be y over 5 because it's opposite over hypotenuse. So y equals 5 times the sine of 29. Let's do that real quick. So 5 times sine of 29 equals
Is that a Bucky shirt? It is a Bucky shirt. I love Bucky.
2.42-ish. Okay. Round to the nearest hundredth. Okay, we just did. So cosine of 29 equals x over 5. So x equals 5 times the cosine of 29. So let's do that. 5 times cosine of 29. 5 times the cosine of 29. Okay, and that equals the wrong answer.
Sick.
Magnum zero, because we already have two sides.
Oh, what did I say? Oh, yeah, no, we're right. We're right. 4.37 approximately. Okay, so that's the x and the y value. So that means our decomposed vector looks like this. So do the little component form. Your x value goes there, 4.37, and your y value goes here, 2.42. All right? Can you do that?
Sure.
We'll never find out.
All right, what was that? Was that 19? All right, last
Hopefully we're right down.
Last question of geometry.
Are they watching a Disney movie?
They're watching Wall-E.
They are watching Wall-E. We walked in on
I
it the
wanna
other day.
watch
It was
Wall-E.
fun.
Why
Describe
can't
the
we watch Wall-E in my
cross-section
physics
of the
class?
solid below. This is what we're ending on.
Wait till you
What does the
finish.
cross-section look like? Can you see it?
I cannot.
Wearing a hat.
It looks like it's wearing a hat.
Has a paper hat on.
Yeah.
It's a little
Hello, my baby. That's what it looks like. What is that cross-section? What is it? What shape does it make?
A triangle.
It's triangle. It's very important that you say triangle, not pyramid. Pyramid is what is cut off if you were to cut that off. But the cross section is the shape that makes, okay, the actual cut, not what you're cutting off, but the actual cut is a triangle. Got it, Kate, Neva, Kava?
Kayla!
All right. We good?
Yeah.
Congratulations. That was geometry.
Black math. Give me some math and I'll give you some flack. Black math.